Hello, this is an overview of cs888. So there will be two offerings of cs888, but this video is about my offering of cs888. So rendering is a process of generating images on computers, which has a wide variety of applications such as visualization in industry or making feature film like this one. So rendering is really a process of generating images based on input data such as light sources, information about light sources, the shape of object, and so on. And the resulting images may or may not be photorealistic based on what you want to achieve. But in this course, we are focusing on rendering based on computer simulation of light. Because it's going to simulate the physics of light, it's going to be automatically photorealistic. And it is sometimes called a physically based rendering in computer graphics. This topic is really interdisciplinary by nature because it involves computer science, of course, but it also involves the physics of light. And to model the behavior of light so that we can simulate this on computer, we're going to need to use mathematics, and it also involves lots of other topics such as perception and art. So it's going to be things that you're going to learn in this course is going to be useful. Many things beyond just computer science, or actually just beyond computer graphics. Goals in this course are as follows. First, I want you to do, of course, make you familiar with a range of techniques and tools in rendering to catch up with what's going on in this field. But also, I want you to build an experience of reading papers and evaluating, so reading and evaluating technical papers, and then also giving a presentation about those. Last but not least, I hope you can find a topic that you find really interesting in rendering and you want to study further after you took this course. In terms of evaluation of this course, there will be three parts. The first part is about presentation, which accounts for 40% of the final grade. So you're going to most likely give two presentations about this course, and then you're going to be evaluated on the clarity, correctness, and then how you read the discussion afterward. Another 40% is on reviews. So you're going to write the review per week for one of the papers you have read. And last 20% is going to be on the participation of discussion in this course. So talking about papers, you're going to be reading 4 papers per week. All of them is about the same topic within rendering. And 4 papers will be selected out of 6 papers that are pre-listed on the course web page. And each paper will take roughly a few hours to read. And in case you need to give a presentation, maybe you need to spend more time than a few hours. For presentation, you're going to be given 2 presentations throughout the course, and there will be 2 talks per class, and then you need to prepare slides on the talk for each of the papers you assign. Length of your talk should be roughly 20 to 30 minutes, and there will be a discussion afterward for each of the talk. And you are responsible for reading the discussion afterward, but of course, I'm going to be moderating the discussion. For reviews, you'll be writing, you're going to be selecting one of the 4 papers you have read and write 1 or 2 pages review for this paper that you selected. And we're going to provide a template that you can just fill in, but writing itself probably should take an hour or so. It's going to be due before the week we discuss the paper. So for each week, you're going to be writing review for the papers we're going to discuss in next week. So for the schedule, for the first 2 weeks, I'm going to give lectures about the basic ideas of light transfer simulation and the physics-based rendering. And also I will be talking about how you read papers and how you discuss papers and so on. The rest of the weeks is going to be spent for seminar weeks, seminar sessions. So for each class, we will have 2 talks given by you and followed by discussion. There will be no midterm or final in this course. So let me tell you a bit about the topics that are going to be covered in this course. One of the topics we cover is acceleration data structure. So this is about making what's called the ray tracing algorithm, which is a building block of light transfer simulation and physically based rendering as fast as possible on computer. So this is all about algorithm and doing high performance computing. So we're going to be learning how we can run this computation as fast as possible using techniques developing computer graphics. Another topic, we're going to take a look at the materials. So this is about making mathematical models for appearance of objects. For example, let's say we want to have an equation that models the scratches on this spoon, then we need to have some sort of equation that tells us, this is how the light is going to be reflected on this spoon. So this is about optics and also algebra combined, so that we can have a mathematical model appearance. Yet another topic we're going to cover is a rendering system. So this is about designing a system for generating images, like essentially rendering system on modern computers. So this is about software engineering and also high performance computing, because we need to deal with a large amount of data and also do this computation really quick. So these are some of the topics we're going to cover, but there will be essentially more topics we want to cover, and I hope to see all of you in the CS88.